We're going to look at the concurrencies or the centers of triangles in this video. We have a few lines or a few words that we need to set out first. Starting off, a bisector is a line which cuts another line in half, so it bisects it. A median then is the line from one vertex to the midpoint of the opposite side. Okay, so that's going to come up later for us. The centroid is sometimes called the center of gravity of a triangle, and it is the point of intersection of the medians. The line from one vertex perpendicular to the opposite side is going to be the altitude. Okay, then the orthocenter is the intersection of the altitudes. A mediator, so similar to kind of a mediator is a perpendicular bisector of a side of the triangle, and the circumcenter then is the point of intersection of the mediators. So a triangle has a number of different centers, and we're going to look at three of them here. So the centroid, the orthocenter, and the circumcenter. And you need to be able to find the coordinates of each of these centers for a given circle. So it's really actually important that as much as being able just to find the centers of these triangles, you need to know exactly what each one is. Do you know what it's the intersection of? And then that will help you with how you're going to find it. Okay, so if we look at the first one, the centroid we said is the center of gravity. It's sometimes called the balancing point of the triangle, and it's the point of intersection of the medians, which are the lines from one vertex to the midpoint of the opposite side. And the centroid divides the medians into a 2:1 ratio. So what we mean by that is that this part here is twice as long as that part for each of these medians. We can kind of see it visibly there, how that would kind of look. So to find the coordinates of the centroid, we're lucky enough for this one that there's a simple formula that we use. And the formula for the centroid is x1 plus x2 plus x3 divided by 3, and then y1 plus y2 plus y3 divided by 3. So it's kind of an average really of the x coordinates and an average of the y coordinates. And that's for a triangle with vertices of x1, y1, x2, y2, so on and so forth. So to find the coordinates of the centroid, if we're given the coordinates of the triangle, we can set out our formula of x1 plus x2 plus x3 over 3, y1 plus y2 plus y3 over 3. We can then fill in the different coordinates that we have here. 3 and 3 plus 2 minus 2 over 3. And that's going to give me, let's see, 12 over 3 and 3 over 3, which of course will give me 4, 1 as the centroid of this triangle. Okay, so the centroid is quite a nice one in that we just have to reproduce the formula and then we're subbing in. It's fairly straightforward then once you know the formula there. The orthocenter then. Orthocenter is the point of intersection of the altitudes. And the altitude is a perpendicular from one vertex to the opposite side. So you can see here it's a line that starts at one of the vertexes and then is perpendicular to the opposite side. Now it just has to be perpendicular to that opposite side. So to find the coordinates of the orthocenter, well, we need to look at these lines. If we look at this line here, so if we think about how we found the equation of any line, to find the equation of a line, we need a slope and we need a point. So the slope, well, it's going to be perpendicular to the opposite side. And then in terms of finding the point, it has to go through the vertex. So the point is going to be that vertex that it has to go through. So in order to find the equation of this line, we will have to find the slope of the opposite side and then use that in finding the slope of the perpendicular line. Then once we've done that for two sides, we'll be able to find the intersection of those two lines and use that then in finding the coordinates of the orthocenter. So if I'm given a triangle with these three vertices, I can pick one side, so say AB, and I'm going to find the slope of that side AB. So to find the slope of AB, that's y2 minus y1 over x2 minus x1. That's going to give me 3 over minus 6, which is, of course, minus a half. What that means for us then is the slope of, we're going to call C, we'll consider that to be the altitude that's going through the point C and going to the other side. And we're going to say that the slope of that one then will have to be 2, because remember the slopes have to multiply to give minus 1 if they're perpendicular to each other. So knowing that, we can now get the equation of this line using the point C. So y plus 3 is equal to 2 on x plus 1, And we can tidy this up a little bit, getting it into the correct format. Is equal to 0. Okay, let's see how much space we have. Lovely. Okay, once we have that, then we need to do the same for one of the other sides. So this time maybe we'll do AC. So looking at C, so y2 minus y1, x2 minus x1. Minus 5 over minus 5, which is of course just 1, which means that the slope of the line through B will be minus 1. So 1 over 1 becomes minus 1 over 1. And again, we'll use our point B this time, which is minus 2, 5. We can similarly tidy and adjust as we see fit. Now that we have our two equations here, so we have x plus y minus 3 and 2x minus y minus 1, we can do a simultaneous equation here. So I'm going to rewrite so that we have x plus y plus number. So I get 3x is equal to 4. So x is equal to 4 over 3. And then subbing back into my formula, I get that y is equal to 3 minus 4 over 3, which of course is going to give me that y is equal to, let's see, 5 over 3. So my orthocenter is going to be 4 over 3, 5 over 3. 4 over 3, 5 over 3 there as my orthocenter for that one. Okay, bearing any mistakes. Okay, lastly we're going to look at the circumcenter. So the circumcenter is the point of intersection of the mediators, which are the perpendicular bisectors of the side. So not alone does a mediator have to be perpendicular to the opposite side, it also has to bisect it. And to bisect means it's going to go through the midpoint, because it's going to have to cut it in half. So where we had for the previous option when we were looking at orthocenter, we said it had to go through one of the vertexes. This time now it has to go through one of the midpoints. So it'll have to go through the midpoint of the opposite side. So to find the coordinates of the circumcenter like we have labelled here, we find the equations of the perpendicular bisectors. So the slope will be that it has to be perpendicular to whatever side we're looking at, and the point that it's going to go through is going to be the midpoint of the side that we're looking at. Okay, so we can see here that it's perpendicular here and also goes through the midpoint here as well. Let's find the coordinates of the circumcenter of this triangle with vertices A, B, and C. So let's first of all find the slope of AB. Okay, so minus 2, minus 2, minus 4, 2. So I get minus 4 over minus 2, which is of course 2. So then the slope of my mediator, we'll just call it M1, is going to be minus a half. Okay, then we need to find the midpoint of AB. And the midpoint, of course, we should know from our formulas, is that we x1 plus x2 over 2, and then y1 plus y2 over 2. So I get that my midpoint this time is going to be minus 6 over 2, 0 over 2, which is of course minus 3, 0. Then to get my line, so this is going to be my first line, so y minus 0 is equal to minus a half on x plus 3, y is equal to minus a half x minus 3 over 2. We can multiply across by 2 there to get rid of those fractions. And again, then we can just tidy up into a format that we'll be able to work with. So we get x plus 2y is equal to minus 3. Now we're going to do the same thing for one of the other sides. So this time maybe we'll do AC, MAC. So we'll find the slope of AC. So that's going to be minus 5 minus 2 and 5 minus 2. So it's plus 2. So minus 7 over 7, which is minus 1. So my second slope is going to just be 1. Then again, we need to find the midpoint of AC. So the midpoint of AC is going to be minus 2 plus 5 over 2, and 2 minus 5 over 2. And that is going to give me 3 over 2 minus 3 over 2. Then to find my second line, it becomes y minus 3 over 2 and 1 by x minus 3 over 2. And again here we're just tidying up at this point. We can multiply across, or we not even worth our while really multiplying across here by the 2, because we'll actually get it simplified for us just by bringing the 3 across there. Okay, so we have our two equations now. So doing those then as a simultaneous equation here. So we have x plus 2y is equal to minus 3, and x minus y is equal to 3. So we'll multiply this one by 2. So we get x plus 2y equals minus 3. 2x minus 2y is equal to 6. So we get 3x is equal to 3. X is equal to 1. If x minus y is equal to 3, 1 minus y is equal to 3. Minus y is equal to 2. So y is equal to minus 2, which implies that my circumcenter is going to be 1 minus 2. So again, the same thing with, I suppose, the previous ones as well. The key thing really is to identify which center you're looking for and then know the steps involved in finding that center. So whether it's the altitude, whether it's going to be the mediator, and even if you don't know those words exactly or can't remember those, that you're still able to work out exactly the steps involved. So the circumcenter, I suppose, is maybe the most involved one, where you have to find the midpoint as well. The orthocenter, we just are going using one of the vertices and that perpendicular side as well. Right. So we'll look at an exam question. So we're trying to find, first of all, the equation for line 3b, which is perpendicular to AC. So fairly straightforward. So equation 3b perpendicular to AC. So we need to get the slope of AC first. So 4 plus 2, so 4 minus 2. Minus 3 minus 6 gives me 6 over minus 9, which is minus 2 over 3. Meaning the slope of the line 3b will be 3 over 2. So finding that line then, gives me 3 over 2x minus 15 over 2. I can multiply across by the 2 there to eliminate that fraction. And I get 3x minus 2y is equal to 9. So 3x minus 2y is equal to 9. So we can write it. I'm kind of looking ahead at where we're going to be going, so we're just going to set it up this way. Looking at part B then, we're asked to find the coordinates of the orthocenter. So what we found in the first part is actually one of the parts of finding the orthocenter. It's one of the altitudes. We need to pick another side now, so we could pick maybe AB and find the slope of AB. So 3 minus 2 again, so 3 plus 2, and 5 minus 6, and I get 5 over minus 1, which is minus 5. Gives me that the slope of C is just going to be 1. Then finding that line, we'll go up here. So y minus, and we're looking at C, so y minus 4 over 1 by x plus 3. So y minus 4 is equal to, 1 over 5. You're forgetting something. So just rearrange this here. Y minus 4, 1 over 5. So 1 over 5x plus 3 over 5. We can multiply across by the 5 there. So 5y minus 20 is equal to x plus 3. And again, tidying up, x minus 5y is equal to minus 23. So taking those two lines now, so this one here and the one from the first part, we can rearrange those in a simultaneous equation. Minus 2y equals 9, x minus 5y equals minus 23. We're going to multiply this bottom one by minus 3 in order to have the x's lined up. Minus 2y equals 9, minus 3x plus 15y equals 69. So we get 13y is equal to 78, which means that y is equal to 6. Subbing that back in then, x minus 5 times 6 is equal to minus 23, which means that x is equal to 7. So my orthocenter will be 7, 6 for that question. Okay, so for that one there, they're kind of leading you through it. The first part had you finding one of the altitudes, and then you had to know that you had to recognize that, I suppose, and use that then to find the second altitude. So looking then at the second exam question, so this is 2017, ABC is a triangle where the coordinates of A and C are given, and G is the centroid, and we're told AG intersects BC at the point P, so we'll maybe just say that P is around about there. We have to find the coordinates of P, so we want to know where the line AG is going to intersect with the point P there, with that point P. So we could find the equations. We could find the equations of those lines. We can also kind of establish that the centroid is the vertex from one side to the midpoint of the opposite side. Now we don't know what the coordinates of B are, so we can't actually just use the midpoint formula to do that either. The last thing that we're told is the distance from A to G, and the distance from G to P is in a ratio of 2:1. So that's what we're actually going to have to use in order to answer this question. So starting with A, which is 0, 6, we know that G is 2/3, 4/3, and then we don't know what P is yet. Okay, that's what we're going to try and find. To go from A to G, I would need to add on 2/3 to my x coordinate, and to my y coordinate then I would have to take away 14/3. I would have to subtract 14/3 to my y coordinate. And following the ratio that we have, this is in a ratio of 2:1. So what I do to go from A to G, I need to half that in order to go from G to P. So instead of adding on 2/3, I'll just add on 1/3. Instead of taking away 14/3, I will just take away 7/3. So looking at that, then that's going to give me 1 here, and it's going to give me minus, so 4/3 minus 7/3 is going to give me minus 1. So I get that P is the point 1, minus 1. Looking then at part B, we're asked to find the coordinates of B. So we know what the centroid is, so let's use that formula. So my centroid is x1 plus x2 plus x3/3, y1 plus y2 plus y3/3. So filling in the values that I do know, so I can use A and C. So 0 plus 4 plus x3/3. And for the y coordinates, it is 6 plus 2 plus y3/3. And that is equal to my centroid, and my centroid is 2/3, 4/3. So that means, of course, then if I take, first of all, the x coordinate here, taking the x coordinate, that means that 4 plus x3 is equal to 2, so x3 is equal to minus 2. And then taking the y coordinate, I get that 8 plus y3 is equal to 4, so y3 is equal to minus 4. So that means that B is minus 2, minus 4. That's my answer for that second part. Looking now at the last part, we are asked to confirm that P, or prove that C is the orthocenter of the triangle ABC. So we need to find the orthocenter. So orthocenter is intersection of the altitudes, and that is the perpendicular from one side So it's the perpendicular from the vertex to the opposite side. So let's just pick two sides. We'll first of all go maybe with AC. So find the slope of AC. So that's going to be 2 minus 6 and 4 minus 0. So that gives me minus 4 over 4, which is minus 1. So that means that the slope of the line through C will just be 1. And then finding that line, y minus, we're using the coordinates for C, or sorry, not C, for B. So using the coordinates for B, so y plus 4 is equal to 1 times x plus 2. Y plus 4 equals x plus 2, and tidying that up, x minus 4 is equal to 2. We can pick one of our other sides then, so maybe we'll do AB this time. So again, using that there, so minus 4 is 2, and looking at A then, so A is 0, 6. Minus 6 minus 0, so minus 10 over minus 2, which is 5. Then looking at the line through C, that would be minus 1 over 5. So y minus, and we look at the coordinates for C, which is 4, 2. So y minus 2 is equal to minus 1 over 5, x minus 4. So y minus 2 equals minus 1 over 5x plus 4 over 5. We can multiply across by the 5 here to get rid of the fractions. And we're following the same steps a lot of the time here. So x plus 5y is equal to 14. So now taking my two lines here that I have. So x minus y equals to 2. X plus 5y equals to 14. Let's multiply this one by minus 1 to get x minus y equals 2 minus x minus 5y equals minus 14. That gives me minus 6y is equal to minus 12. Y is equal to 2. So it's looking promising. X minus y is equal to 2. X minus 2 is equal to 2. X is equal to 4. So that means that my orthocenter is equal to 4, 2, which is equal to C, which is what I wanted to show. So going back over all of that, so there is a lot in finding all of those centers. So you have to be confident that you know the difference between each of the centers and that you're able to then apply that to your questions, that you can easily find the orthocenter, that you know what's involved in that, that you know what's involved in finding the circumcenter, that you know what's involved in finding the centroid, that you know those formulas off. Along with that, we also have the constructions of those centers that we looked at as part of this chapter. Now they will come up again when we do geometry, but it's worth kind of going back over them here. So I'll put those videos, I'll add those videos to this playlist as well, looking at the constructions for finding each of those centers that we've looked at. So you have your centroid, your orthocenter, and your circumcenter. So you should be kind of confident in finding the three of those fairly fluently then.